In this video, I'm going to talk about how to load balance traffic between two ISPs. So let's say that we have a remote office here. Say that this topology is a remote office. And as you can see, we have C1, C2, ISP1 or P1, ISP2 or P2. And we have our LAN here. Basically, all the devices down below here are all layer 2 devices. So each link is configured as a trunk link. So as you can see here. And also the links going to the Z routers. So this is a trunk link, this is a trunk link, and these are all trunk links. And of course the links here are all access links or access ports, configured as access ports going to the hosts. So basically I have two VLANs. I have VLAN 10 and 20, and we want to configure our C routers to load balance the traffic between the ISPs. So in our scenario, we want to use this link here for our VLAN 10 and this link here for our VLAN 20. So basically we have C router is the active router for VLAN 10, and this is its physical IP address on the interface. And of course C2 is the standby router. This is the IP address of the C2 on its gig 0/0/1 interface. And C2 is the active router or primary router for VLAN 20. And CE1 is the standby router for VLAN 20. So as you can see, I have configured all these both routers with HSRP. So these are the virtual IPs. This is the virtual IP for VLAN 10, and this is the virtual IP for VLAN 20. And let's just assume that there is an IBGP peering between CE1 and CE2, but this version of Packet Tracer doesn't support IBGP peering yet, so it's not possible to do that in this scenario. But still, we are able to manipulate or to configure these routers here to load balance the traffic between P1 and P2. So let's go ahead and check C1, and I have configured all the routers, so you don't have to worry about that. So I'm just gonna show you the configurations of HSRP. So basically I configured this link here. Let me show you the configurations. So this is this link here. So basically I'm using sub interfaces for the networks. So for example, for VLAN 10, this is our C router. Like I said, is the primary router for VLAN 10 because it has a priority of 200. And like I said, this is the virtual IP and this is the physical IP address on the interface. And C1 is the standby or backup router for VLAN 20, and this is its IP address, the virtual IP, and the priority. So C1 has a priority of 200 for VLAN 10 because we want VLAN 1 C1 to be the active router for VLAN 10, and of course C2 has. Let me go to C2. Show. So they have the same interfaces. Let me just show you the configurations here and compare the configurations of. Let's compare the configurations of CE1 and CE2. So like I said, CE2 has a priority of 150 for VLAN 10 because we want CE2 to be the backup router for VLAN 10, and CE2 has a priority of 200 because we want it to be the active router for VLAN 20, and C1 has a priority of 150 because we want it to be the backup router for VLAN 20. So that's pretty much it. That's basically the configurations of HSRP on both routers. And of course, C1 has an IBGP peering with PE1, and P1 has an IBGP peering with RR, or remote router, and PE2, C2 has an IBGP, did I say I? To be E, external BGP peering with PE2, and PE2 has an eBGP peering with remote router. So the purpose of this video is just to demonstrate that, like I mentioned earlier, that we can configure our C routers to load balance the traffic between the ISPs. We don't want one of the link sitting and not being used. So we want both links to be used. So I have some hosts here, actually 4 hosts, and this host here, PC here, is configured to be on VLAN 10, and this here is configured to be on VLAN 20, and this here is configured to be on VLAN 20, and this here is configured to be on VLAN 10. So let's check and actually ping the IP here and see, or actually trace. This is a Windows PC, so we're gonna use traceroute instead of traceroute. So we are trying to traceroute this here on. Let's say that this is on the internet, and let's find out which link PC is gonna use to get to that to get to that IP address. So PC0 is, as you can see here, is configured to be on VLAN 10, so it's gonna use its primary or active router, which is CE1. So this is the IP address on CE1 port gig 0/0/1. So let's check this PC here. This PC is configured is a member of VLAN 20, so it should be using the link here, CE2 and PE2 link, to get to that network. So let's verify that. Okay, as you can see, it's using this link here, and we can verify that because this IP here is the IP address of the interface here. So we have successfully demonstrated or verified that we can configure the C routers to load balance traffic between the ISPs. So I'm gonna actually try to shut down this or bring down this port here and see if this PC here is still able to get to this network here, because CE1 is CE2 is the standby router for CE1 for this network here. So I'm gonna go ahead and actually bring down that interface. This is the interface. Oops, should be shut down. Okay, so the interface just went down, as you can see here. So forgot to do a show standby, but we can actually still verify it. Show IP, show standby, brief. For some reason, it's still seeing itself as the active for VLAN 10, but that should not be the case. I think this is just a bug or something, so I'm not really sure, but CE1 is not able to communicate with CE2 on the networks that are configured with HSRP. So this here should be incorrect. Yeah, it's still seeing itself as the active router for VLAN 10, but you can actually verify here that PC0 is actually using this link here. 10.1.1.253 is CE2 IP address for VLAN 10, and let's check PC1, which is on VLAN 20, and do the same command. Okay, so basically it's still using its router, which is CET router on VLAN 20. I mean this IP here on VLAN 20. So we have verified that if the link here goes down, the PC on VLAN 10 is still able to get to this network by using the backup link here. And actually the same thing is going to happen if we bring down this interface here. All the traffic will use this link here to get to that network. Let me see. Let me do a show standby brief. Okay, so it's still seeing itself. I mean, it's seeing itself as the active router for VLAN 10 and active router for VLAN 20. I'm actually gonna show you that. And I bring this port back up. I'm gonna no shut this port here and actually verify the HSRP status. Show standby brief. So it still is communicating with C1. So okay, so this is now it's showing the correct state of each VLAN. So for VLAN 10 or group 10, C is the active router, and it is the standby router for VLAN 20. And this is the this is its IP address. I mean, this is actually the IP address of hold on. So local, this is the local, I mean the active router for VLAN 10 and the standby router for VLAN 20. Let's actually go to C2 and compare the HSRP status. So C2 is the active router for VLAN 20 and it's the standby router for VLAN 10. Standby local. Okay, so standby this. Okay, so basically this is, so meaning this is the IP address here is the IP address of the active router, and here in this column local, meaning that this is the standby router for VLAN 20, and same thing here. The local active router for VLAN 20 is this router that we are on right now, and the standby router is the IP address, is the router that has this IP address here, which is VLAN 10. All right, so yeah, that's all I can talk about how to load balance traffic between two ISPs in Packet Tracer. Thanks for watching.